Ahoy hoy, I'm Planarwalk, and recently I've been bringing up Cavendish to explain to flat earthers that gravity exists. And they seem to go, nope, that's not an experiment because the independent variable is gravity and you cannot change gravity, therefore it is not an experiment. When in actuality, the independent variable is not gravity, it is mass. Now, you'd think that I'd be able to just explain that and move on. But nope, I can't because they've mixed a few things up. Now, this may not apply to all flat earthers, but it certainly applies to Nathan Oakley and people that think like him. You see, he's got mixed up the cause of something with that which precedes the event happening. You see, if I pick up a coin and drop it, what causes it to fall to the ground? Now, Nathan Oakley might say that the cause of the coin falling to the ground was either me picking it up or me letting go of the coin. None of these actually explain why the coin fell to the ground. It's certainly true that if I didn't pick the coin up and let it go, that it wouldn't fall to the ground. That is true. But the forces acting on it once it leaves my hand, what are those forces? You can't say that it's me because I am no longer applying any force to it. In fact, when I was holding it up in the air, I was then applying force to it to keep it up in the air. But when I let go, I'm no longer applying any force to it, so I'd say the cause of the coin falling to the ground is the force that's acting upon it. And this brings me to my main issue, which is an issue that applies to many more flat earthers than just Nathan Oakley. In scientific experiments, the independent variable is not necessarily the cause. The best way I can explain this is with a programming analogy. When writing code, you will often test that code to see if it is working properly. A common way of testing is Blackbox Testing, and this is very similar to scientific experiments. So you start with an input, and based on that you come up with what you expect the output to be. This is pretty much your independent variable and your hypothesis. So next you'll take your input, run it through the program, and see what the output is. After that, you compare your results to what you thought was going to happen and see if it was correct. Now, if you had no idea how the program actually worked, you could use this to figure out what's going on inside the program. Now, I have actually written a program, and when I input 10 into that program, I get a result of 90. Now, based on this, you could say that the output is 9 times the input, but that breaks down when I tell you that the output for 9 is 72. Now, I'm not going to tell you the process for turning 10 into 90 and 9 into 72. Instead, I want you to work out what's going on in the program. Take this data and work out what's going on in the program. If you think you know, let me know in the comments. I'll pick one of the correct people to come on my podcast. Now, if you've been paying attention so far, you'll notice that the input, or the independent variable, whatever you want to call it, does not cause the result. Yes, it does have an effect on the result, but that is not the same thing as saying that it causes the result. The cause of the result is instead the processes that happen. In the case of the Cavendish experiment, the independent variable is the mass of the lead balls. The result is that these balls move towards each other. The cause is gravity. Leave a like and subscribe if you liked that video. Leave a dislike if you're Nathan Oakley. Go ahead, Nathan, go on, I know you want to. Leave a comment of what you think the answer to my little question is. And join my Discord if you want to talk to me later. But anyway, I will see you in the next video. Between you and me, thank you for watching.